In the previous session, we seen that Z parameters, how to find Z parameters of a network, any network, what is two-port network. This is the Y parameters now. Let us see Y parameters. Y parameters is nothing but admittance parameters. Admittance is the reciprocal of impedance. The reciprocal of impedance is called admittance. Y equal to 1 by Z. That we have to remember. Admittance parameter, the unit of admittance is Siemens or mho. The property of element which allows the current flowing through it. Oppositely, it acts. Admittance is the reciprocal of impedance. Impedance opposes the current, whereas admittance allows the current. It is denoted by the capital letter Y and measured in Siemens. Y equal to, what is Z? Z equal to R plus JXL. Y equal to 1 by R plus JXL. Y11 equal to I1 by V1. How we written Z11? The reciprocal, the suffix, the Z11 is represented by V1 by I1. How to find Z11? V1 by I1 at I2 equal to 0. This suffix only plays important. Y11 equal to I1 V1. Like that we can calculate. The Y parameters also known as short circuit admittance parameters. Short circuit, because we are doing open circuit in impedance parameters, whereas in short circuit parameters, we are doing Y parameters, we are doing short circuiting the load. One of the port is short circuited. Previously, one port is open circuited. From that, we calculated impedance parameter. Y parameters are by doing short circuiting this load terminal and voltage supply terminal. Input port is short circuited, output port is short circuited. After that, we will calculate Y parameters. Consider a two-port network like this. This consists of so many resistors. V1 is the input voltage, hence it is a input port. Input port it is input port. It is output port. I2 is the current flowing in the load, and I1 is the current flowing in input. Let V is the input port voltage, I1 is the input port current, V2 is the output port voltage, output port current. By the principle of superposition, I1, I2 can be represented in the form of function of V1 and V2. Previously, V1, V2 represented in terms of Z parameters I1, I2. But here, current will be represented as a function of voltage and voltages V1, V2. I2 current also represented in the function of V1, V2. That we have to remember. From superposition principle, we can write the equation I1 equal to Y11 V1, Y12 V2. That we have to remember. Previously, Z parameters how we written? Similar to that. I2 equal to Y21 V1 plus Y22 V2. Writing the two equations in matrix form, these equations we have to remember. For Z parameters and Y parameters, these two equations we have to remember. Writing the two equations in matrix form, these two we represented in a matrix, and these coefficients of V1 and V2 represented Y11, Y12, Y21, Y22. After that, it is V1, V2. This matrix is called admittance matrix, Y, V1, V2. Y parameters are obtained by doing only one of the port is short circuited. That is V1 equal to 0 or V2 equal to 0. If you substitute V1 equal to 0, you will get V2, Y12 equal to Y12 equal to I1 by V2. What is Y? Y equal to 1 by Z, or Z equal to V by I. You know that Z equal to V by I. The reciprocal of this Z is admittance. Hence Y equal to I by V. The reciprocal means we have to reverse this. If you substitute V1 equal to 0, when V1 becomes 0, when input port is short circuited. When input port is short circuited, V1 becomes 0. If you short it, then V1 becomes 0. If you substitute V1 equal to 0, then you will get Y12. Y12 equal to I1 by Y12 equal to I1 by V2. This suffix indicates I1 by V2. Case 1, when our output port is short circuited, V2 becomes 0. This is V2, V2 becomes 0. When output port is short circuited, it becomes V1 will be there. Substitute v2 equal to 0 in equation 1. If you substitute v2 equal to 0 in equation 1, you will get y11, I1 by v1. Similarly, substitute equation 2, v2 equal to 0, then you will get y21, I2 by v1. Another case 2 is input port is short circuited. Now this one becomes short circuited, v1 becomes 0. I1 will be there. In short circuit, current will be there, voltage becomes 0. That we have to remember. This load will be having voltage V2. Substitute V1 equal to 0 in equation 1 and 2. In equation 1 and 2, if you substitute V1 equal to 0, then you will get Y12. The same thing we are representing here. You can see substitute equation 1, V1 equal to 0, Y12 equal to I1 by V2. Substitute V1 equal to 0 in equation 2, we will get Y22 equal to I2 by V2. Then the equivalent circuit for Y parameters are this one. Y12, V2 is the dependent variable, and I1, Y11 is the independent variable. We can represent like this. Find admittance and Y parameters. Based on these problems we'll do now. Similarly, previously also one problem we left here. Find Z and Y parameters for the network shown below. Let I1, I2 be the two currents. Assume that two currents are in same direction. First, we will find Z parameters. Reciprocal of that, we can calculate Y parameters. Or let us see one problem. Find Z and Y parameters for the circuit shown below. It is 1 ohm, 1 ohm, and this one 1 by 2 ohm, 2 ohm. There are how many loops are there? One loop, another loop, another loop. Three loops are there. Let I1, I2, I3 be the currents, loop currents. You can assume the currents in different direction. According to that, we have to find Z parameters. Find Z and Y parameters for the circuit. We know that for Z parameters, what is the equation? V1 equal to Z11 I1 plus Z12 I2 made as equation 1. Write the equation 2 also for Z parameters. Apply KVL for loop 1. If you apply KVL for loop 1, V1 equal to I1 plus 2I1 minus I3, you can write, because this direction is opposite. If you assume minus I3, V1 equal to one equation you will get V1 equal to 3I1 minus 2I3. Make it as equation number 3. Apply KVL for loop 2. If you apply KVL for loop 2, there is no voltage source. Voltage source becomes 0. KVL for loop 2. Assume that it is a loop 2. It is loop 2. Current is I2. Current is I1. Apply KVL for loop 2. V2 equal to 1 by 2 I2 plus I3. Those two currents are in same direction. The two currents are in same direction. I1 plus I2 plus I3. V2 equal to 2I1 plus 2I3. You can write one equation. Apply KVL for loop 3. If you apply KVL for loop 3, according to the direction of currents you assume, KVL for loop 3, if you assume 1 ohm current is only I3. 1 I3, 1 into I3 plus 2 into I3 minus I1 plus 1 by 2 I3 plus I2. If you solve this, you will get I3 as I2 by 7. Make it as equation 1. Another equation 5. Substitute equation 5 in equation 3 and 4. You will get V1 equal to 13 I1 by 7. Compare the equation with 1. Then you will get Z11 is 13 by 7, Z12 is 2 by 7. Similarly, V2, if you substitute there, then you will get V2. Again, compare this with equation 1. Then Z12, Z22 you will get. First, find the Z parameters. After that, Y parameters. Admittance is the reciprocal of impedance. Y equal to Z inverse. Find the Z inverse. Then one of the simplest method is, if you know Z parameters, how to calculate? Y equal to 1 by Z, Z inverse. This Z matrix, inverse we are applying. Inverse, by applying inverse, Y equal to Z parameter, Z inverse by AD minus BC. If you do determinant of that, AD minus BC, and this will be changed. 3 by 7, 13 by 7, 2 by 7, minus 2 by 7. Here we are adding signs. These are altered. 3 by 7, 13 by 7. Then this is the Y, Z inverse matrix. Then you will calculate Y parameters. Similarly, find Y parameters for this network. For Z parameters, first find out. After that, Y parameters you can calculate. Or directly you can calculate by using another method. Y parameters is the reciprocal impedance. Again, you can calculate. Find the Y parameters for the below network. It is very simple. Find the Y parameters for the below network. For this network, it is V1, it is V2, and it is plus and minus. The currents you can assume in various directions. If you assume one direction, same direction, you have to add V1 and V2 equations from Z parameters you written. Apply KVL for loop 1. The same direction if you assume I1 plus I2 for this 2 ohm. V1 equal to I1 plus 2 into I1 plus I2. From that V1 equal to 3I1 plus 2I2. Compare with equation 1. You will get Z11, Z12. Apply KVL for loop 2. Then you will get these two Z21, Z22 parameters and write the matrix form. From that you can find Y parameters. How to find Y parameters? Y equal to 1 by Z, Z inverse. We are changing this Z matrix or Z parameters matrix. We are changing to find Y Z inverse. If you want to calculate, these elements will be altered. These two elements will be altered. Replace the positions and sign will be changed for these two. Divided by AD minus BC, 1 by 11. Then Y parameters we can calculate. What is meant by reciprocal network? Define reciprocal network. Y parameters Y12 equal to Y21, then the network is said to be reciprocal network. The Y12 equal to Y21, then it is a reciprocal. Symmetrical network means Y11 equal to Y22, then it is said to be symmetrical network. That's about symmetrical network. Next, we will go for transmission line parameters.